The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on t-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius, up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitry Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really. That had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitry was making a bold statement. He said, and I'm paraphrasing here, y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time. Scandium, germanium, rhenium. The element he called Eka manganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitry predicted its existence, 30 years after he died. Dmitry died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendeleevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitry Mendeleev, the architect of the periodic table, will be staring back.
Good evening.
Hello, good evening.
I thought we'd kick it off with that video because I did mention in one of the earlier shows about how awesome the periodic table is, but I'm like, of course I'm going to say that because I'm a scientist. But it really is amazing because most of the elements that you see there weren't there when the periodic table was first created, obviously. So a lot of this stuff was discovered much after Mendeleev had set up this categorization of these elements. So that's why some of the stuff is it seems like it's misplaced or moved, because a lot of that stuff wasn't there in the first place. But they wanted to follow that that original setup, because it does, like I said, it gives so much information. Every column, every line, every row, every number that you see on there is useful at some point for one reason or another. And I don't know if I can say it in words how efficient this is. Like, it's a very efficient use of space and information. And that's kind of like how things were packaged before the digital and technological revolution and everything was put on a computer chip. But that is kind of the same concept of stacking data that they use for technology and making microchips and all of that stuff, and making them smaller and smaller, but having larger and larger amounts of memory is basically how they program the chips to stack and store information. So I'm not sure how nerdy or techie y'all are, but if you go into like the settings of your computer or your laptop, mostly only on like laptops or computers. I'm not sure if the handheld devices do this, because I haven't needed to do that. But it's a thing on there called like disk utility or disk cleanup at some point. And then if you go in, there's other options and stuff where it'll ask you, do you want to partition your hard drive or do you want to clean it up? And so partitioning is basically just splitting the memory, the amount of memory that's on your hard drive, into one section that's used for something and then another section that's used for something else. And not everybody usually needs to do that. A lot of times people used to back up their computer on their hard drive by partitioning it. And so if something happened to one partition, the other part is safe. So that's what the partitioning is. But when you ask for it to clean it up, basically what it does is there's little holes in the data, or sometimes it's just when it just grabs it from the RAM, which is your temporary memory in your computer, and stores it on your hard drive, it just grabs it and throws it in the first space it'll fit. So all the pieces of data don't necessarily fit exactly together. So you end up with these little empty spaces of data in between all of your data. And so when you ask your computer to clean up, what it does is it reorganizes the data and removes those spaces, so that now you freed up that memory again for you to save or store more stuff, and also for your computer to find what it already has much easier. And so even though, yeah, it still exists in that folder that you put it in or that you saved in or whatever, depending on where you saved it from and how you saved it is going to determine how that data is stacked. So when you clean it up, you restack it, you make it nice and neat and uniform and clean, and it also can help your computer run faster too. So if you've never done that and you have a very, very slow computer, that might be why. But or you can just get a brand new hard drive and then just swap them out, or whatever. There's plenty of options, and the nerdier and geekier you are about it, the more those options are readily available to you. And it also depends on how much time you're willing to put into it, because you definitely gotta know what you're doing, because if you don't do the steps in the correct order, you could end up with a completely different result than a nice, neat, and faster moving hard drive. So that being said, that right back to the scientific method. So there's an order of operations to everything. And a lot of times we stumbled upon them through trial and error. And we've also discovered plenty of elements through trial and error. Sometimes we observe the phenomenon. Yes. So sometimes we observe the phenomenon before we even have a question. So a lot of times the observations produce the questions, or they're a source for research, or they are the hypothesis. And so now you're trying to use an experiment to find out why this thing is, how it works, where it came from, and is it useful? So experiments don't always start at the question. Sometimes you start with noticing something like, oh, the sun comes up at this time, but then it comes up a few minutes later the next day, and a few minutes later the next day, and then you start tracking it and you realize, oh, it's on a cycle. It does this 364 point whatever many days a year, and it continues to come up a little bit later and later and later in the morning until boom, all of a sudden it's up at like 6:30 a.m. again. You're like, where did this happen? So around Christmas time, the 21st, 22nd of December is actually the winter solstice. I want to say it's around that time, but that's why it's called the winter solstice, because that's when the sun starts its journey across the sky over again from the far east side. So I live where my balcony faces the east. So the sun rises on my balcony, so I can actually see it move, and it rises closer and closer to the west as the year draws on. And then eventually the sun doesn't rise on my balcony at all because of the way the building is placed. So it's very interesting to just kind of notice things and then be like, oh, well, why is that doing that? And then that's where the design of experiment becomes so handy. And there are plenty of mediocre scientists that get paid a lot of money to design experiments to figure out why something's doing something. So trust me, there's always money somewhere in the STEM field to do. If you can get really, really good at one thing in the STEM field, you will be very, very valued, because the more we advance, I would say, in technology and the things that we can do and the things that we can build, the less room there is for error. So especially when it comes to things that's meant to replace people in like building cars, like that's a safety issue, because if there's no one watching the machine, how the machine didn't mess something up, or things like that. And also programming, if you have one line of code that's out of sync, you can have a very big problem. Like bridges have collapsed because the decimal was in the wrong place, or there are plenty of things that we've done and and attempted to do that literally blew up in our faces due to miscalculations and human error. So the more you can show that you're very precise meaning you get the same answer again and again. Accuracy is getting a similar answer, or in the ballpark, hitting the broadside of a barn. That's accuracy. You hit the barn. Precision is how tight those hits are when they land. If you can hit the same spot over and over, like you are, man, okay, that's master status right there. But if it's a tight cluster, then you're still good. You still on pro expert level, but that little bit of error is the difference between life and death in so many situations. And medicine, when doctors are doing different surgeries, it's literally that small of a margin of error between their patient living and dying. So the more attention to detail, the more practice you put into the one thing that you do, the more value you can actually get out of that, and the more valuable you are at that thing. Because with all the jack of all trades running around, because nobody wants to pay somebody else to do something, because either you don't have the money or you just really don't want to pay somebody because you don't like spending money. Some people are like that. It's okay. But when you do that, you are now requiring yourself to spread your attention, to attempt to learn something that was probably never meant for you to learn to do. Because if you were, born to be, an artist and draw these beautiful masterpieces, like what are you doing with coding or trying to build a website to sell your art? Find someone who builds websites to sell your art for you, and then you focus on perfecting your craft as an artist. And I think with such a wide open field as fields that are included in STEM, I believe that tends to be one of the bigger kind of double-edged swords. It's like you get it's a lot more value that comes out of specializing, but then you kind of tend to miss the big picture unless you're working in a team with a lot of other people that's across different fields, and then you don't need to know everything to see the connection, because you all can physically see it as you're standing there having conversations, and then they're relating, you know, whatever the topic is that you're talking about to technology, or they're relating it to mathematics, or they're relating it in some type of way to engineering or biology, or, you know, you have all of these different things that completely overlap and that are not really separate, but because these people have mastered their viewpoint, they're much better at communicating things from that viewpoint, and thus disseminating that information in a more efficient and precise manner. So like I said, the efficiency and the precision get, you know, up there the minute you start adding in human life as possible collateral damage for that human error aspect. So we definitely work together with everything, unlike the noble gases. Yeah, we'll head into those, because that's a little bit lighter of a subject, a little bit, but just the overall view, and just the inspiration from that opening video of how this man sat there and looked at these elements and looked at the properties about them, and were able to configure them and arrange them in such a way that he could make very accurate guesses about something he had never seen. Like, just because you see how people move, or when you do something, how they react to that, like, you can tell exactly what's going on with them. A lot of times we just ignore that. Like the whole red flag thing, like, it's not about victim shaming or making somebody feel like they, you know, like they're less than, or like they're not conscious or woke, or, you know, however people like to put it. But the red flag thing is definitely a thing, and depending on how in tune you are with your own, I would say, perspective of people. Because I had a real bad habit of doing that. Like, oh no, I see the good in them, and then, you know, I want to ignore these red flags. Like, people can be good and have red flags at the same time. Like, those two things are a part of our complexity as human beings, and that's why we are not just animals, because we are complex like that. We can hurt people we love. We can lie, even though we're generally honest people, and we do that all the time, whether it's to ourselves or openly or outwardly to someone else. We definitely do all of those things all of the time, and we give ourselves sometimes a lot more concessions and leeway with doing that than we do others, and so we notice it more in others than we do in ourselves. But you gotta understand that if you notice it in others, that means you know what it looked like, so you've done it. Otherwise you wouldn't be able to identify that. And so that is like kind of one of the, I would say, the meshing factors of human life and our wonderful, concise, and efficient and beautifully stacked periodic table. It is complex and all encompassing, and everything on there obviously is found on Earth. Otherwise they wouldn't have been able to identify them. So whether they stumbled upon them or, you know, they isolated them on purpose, the process of identifying them was made easier by sorting. And so that's really what, see the signs so you can help them heal. Exactly. And that actually plays right into the point I'm about to make. Like, we have to categorize people. Like, I know it seems kind of like prejudging and all that stuff, but when people are strangers, that's what you have to do. It is required for your safety. That like, that's one of our general basic human instincts is safety, fight or flight. Does this person make you feel threatened? And if they don't, then they don't go in the threatening person category. So, you know, your actions and things follow that line of perception. So, like I said, it's perception. That might not be who they actually are. They might actually have, you know, a knife, you know, hidden behind their back waiting to stick you, but you don't perceive them as doing that. So you're not going to put them in the threatening category. And so that's why doing your research doing your research is so important before you just hop into experimenting with people, because people are complicated. Like I said, a hydrogen atom has one electron. It doesn't even have a proton. It has one. No, it doesn't have a neutron. Like it barely has any mass. Like a hydrogen, barely any mass, and it has some of the most complicated multi-level calculus problems associated with it I have ever seen in my life. Okay, and this is an atom. Now imagine something that's composed of trillions of atoms and like trillions of cells. Like we have cells aren't even one atom, and you expect to get something that is so complex as a person that's composed of all of this stuff, and we can't even do the math for a hydrogen atom. Like we're not going to get ahead of ourselves now. Okay. So that is, one of the key things that I really do love about science in general is that it makes it easy to make that leap from something tangible, something concrete, something simple, something easy, to kind of extrapolate that into the complexity of what being a human is. And then, we're always asking that question, like, why are we here? Like all of that stuff. And it's like, if you hush up and listen, you will find out. Okay, you will absolutely hear it, see it, know it, understand it, and be able to live it and walk that. And trying stuff, experimenting is definitely a way to kind of get your feelers out there to see what feels right to you. Because a lot of times if you're never even adjacent to your purpose, you'll always feel kind of disconnected, not really engaged. And I know a lot of teens, especially, like I was kind of like in that weird in between space for much of my youth, but they eventually had like more kind of advanced like courses and stuff with a lot more information, because I'm an information junkie, in case you haven't noticed, and I've been like that my whole life. So kids having that opportunity. Okay. All right. So kids having that opportunity to really expand and pursue their curiosities in a safe and controlled environment is definitely our responsibility as adults. And not just kind of leaving it up to how school is set up, or how different things are set up, or the after school activities and all of that stuff. So we definitely have to be an active participant. And so I always love the fact that y'all are here, that the adults are tuning in, and that that is really, like I said, that's really the reach. I want it to be a concerted effort. So yeah, the talk might be like way above where children would normally be able to understand it, but it's the constant exposure to it. So, you might end up, your kid go to class and be like, well, and you know how kids, they love telling you everything that they didn't learn. Well, I heard that hydrogen isn't really a metal. It's a non-metal, but they put it over there with the alkali metals because it has similar properties. But hydrogen is, I told you, hydrogen a plug thug. It could do pretty much whatever it wants to do. So you want it to be an acid, it'll be an acid. You want it to be a base, it could mess around and go and be a base. Like, who knows what it's going to do next. And just everything in that group is extremely reactive. So hydrogen being like the biggest, the most abundant thing. Yep, because y'all be surprised what children can pick up. Train them up. They're just in little houses. Yep, exactly. And then they've been repeated something you thought they wasn't even earshot of hearing at the wrong time. You're like, oh, you heard that? Oh, yeah. They done told on you. So that's the whole group under hydrogen. The lithium, what is it? Because it's a couple of salts, but they're all +1 oxidizers. Yes, lithium, sodium, potassium, rubidium, cesium, and francium. Now, those are all found in the human body. I think maybe except for francium. Don't quote me on that though. It might be in there too, but like in very, very, very small amounts. Like a lot of the stuff that are further down, the rubidium, cesium, and francium are found in much smaller amounts throughout the body. And I think those are mostly only found in the brain. I know for a fact all of them are in the brain. And they actually occur in different areas of the brain in different concentrations. So your frontal cortex, which is basically the center of all your conscious thought, like, oh, what am I going to eat today? Oh, I think I'll have a hit. That's that part of the brain. So there's a lot more sodium found in that part of the brain, which kind of makes sense because sodium is the main way that signals are sent through the body from your brain to your different nerves and all the different organs and things like that. And sodium is very important in your muscle contractions as well. So it's super important, even though we get like way too much in our Western diet situation. Like pretty much everything has sodium in it, way too much. And especially if you're eating those fast foods and stuff like that, ton of sodium. Like the daily recommended, I would say, is probably like about like 1,300 milligrams a day. And this is your entire day. One breakfast like biscuit or something from McDonald's probably has that much in it. So yeah, that's why it's better to cook. And you can get the same thing with like a third of the sodium if you cook it at home. Like if you get the store-bought biscuits and your processed meats, because those aren't that good for you either. But buy all of that stuff yourself at the store and then make it, and you will still end up with way less sodium on your plate than if you went and bought it at a fast food restaurant. So that's my soapbox for that one. But the rubidium is actually found in higher concentrations in your brainstem, and there's actually less sodium concentrated there. So when you think about how I said like sodium is very active and it's involved in a lot of your active movement, so like your muscle movement and things like that, then you can imagine why there's less sodium in your brainstem. Your brainstem is basically right by your cerebellum and where all of your autonomic, so your automatic, like I love that they called it autonomic, but autonomic it has more to do with like the nerves and the brain and stuff. But automatic is what the autonomic nervous system is. It's automatic. You don't control it. You can't think like, oh yeah, I'm gonna stop breathing. No, your body got this. Don't worry. That's our what is this? Human bodies for idiots switch. Like that's what the autonomic nervous system is. Don't worry, you can't mess this up because we got this. So like, when kids like, I'll hold my breath and until that's fine, and they'll fall out and start breathing again because that's what the brain does. And they don't just pass out from lack of oxygen. Like it's almost like a signal from the brain that will knock you out before you actually suffocate yourself by holding your breath so that it can take over and make you start breathing again. So that I can imagine why you wouldn't want that to have the same chemical properties as stuff that you can control with your frontal cortex or your conscious thought. And just kind of having like a little bit of fillers in like the different areas that subject kind of touches on, you can make a ton of connections with a little bit of information. And so that's where my nerd rabbit holes tend to take me. I'm like, oh, what would happen if I ate this instead of that? Or what would happen if I, or like even just researching and stuff, the topics for today. That's where I actually came across the information about the your brain having these different concentrations of. Girl, my phone ringing on everything. That's the only thing about having Apple, so everything is connected. So when one thing starts ringing, everything rings. But having those different concentrations of those salts in around the brain is astonishing in itself, because like we think of our brain as like kind of sitting in this like brain soup and everything is just swirling around in there, but you'll be surprised at how little science knows about the brain, like compared to all the other stuff it knows about, like the human body and other stuff. It knows very, very, very little about the human brain. And even the stuff that is starting to kind of rummage out and bring to the surface, it's still a lot of theory, very abstract. It's not reproducible because it seems like they have like kind of general overarching things like, yeah, you know, your left side controls these functions, your right side controls these functions, but I guarantee you there are people walking around right now whose left side does the opposite and whose right side does the opposite. So that's my I would say like my feeler into science is where does it sit with me? Like when I read information, I'm like, how does this apply to me? Oh, do I notice these things about myself? And if I notice something different, then I look for the information that, you know, that's out there supporting something that's different. So that is definitely one way you can kind of guide your research when you're researching observations, or if you're researching questions that you have. Look into where do you fit into that, because your personal point of reference is very important, because it's definitely going to steer and guide you to what actually will motivate you to dig for the truth. And that's I would say that's probably like the most fundamental thing about science, is that like in its purest form, it's just looking for the truth. And then, you know, kind of all the other stuff comes in, you know, funding and personal accolade and awards and all that other stuff. And then, you know, it can misconstrue a lot of the good stuff about, you know, science and technology, and being curious about all of that stuff and the world around you. Now that I don't know, I went off topic a little bit, I ain't gonna lie, but it was fun. But this is gonna be funner. Is that a word? It's a word. I said it. So the next clip is gonna be of the alkali metals and their reactivity with water.
Potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. But the black coating quickly reappears. There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
Definitely my favorite group, hands down. But the reason why they don't do that in your body is because they're not just random metal hanging around in your body.
Like, what in the world?
Yeah,
That was real.
they turn them into salt. So like the salt that we're probably most familiar with is table salt, NaCl. So that's sodium chloride. You can definitely have like sodium carbonate. Well, bicarbonate is like Na2CO3, because CO3 actually has a different oxidation state than chlorine. So you need more sodium to bind to the one molecule of carbonate. Yes. So that's the fun part of chemistry that people always talk about, the stoichiometry, which is just the balancing of your elements involved in all of the stuff. But however, it is not, like I said, it's not ever going to be found in your body as just regular metal. So when you hear of like trace metals and things like that, a lot of times if they're toxic to you, it's because they are in a metal, in their metallic elemental state. And for the most part, if they're salts, we can usually kind of, pass it with our urine and be fine. But the heavy metals that don't do that, they end up getting stuck in our cells, and that's why we detox. So detoxing, mostly I would say the most effective detoxing is just taking care of your kidneys and liver, because that's what they do. Like they detox your body, and you can eat certain like vegetables and things like that that bind more strongly to the heavy metals and will help them pass from your body. And there's plenty of lists and stuff out there that give that information. But our trace metals, those alkali metals, are, like I said, vastly important to a lot of our bodily and cellular functions, because in their salt form, they're very ionic. So those are highly reactive on that side of the table, as you can see. They're extremely reactive with water, which our body is mostly water. And so that being said, having low, what they call electrolytes, having low electrolytes usually means you have a deficiency in one or more of those minerals in your body. And it's those things that are they're pretty easy to kind of come back from if you're not already in like a bad state with that. But for the most part, the symptoms tend to be moving enough to where you're going to notice it before it gets to a life-threatening state to where you can't reverse it with just eating more vegetables. Because for the most part, all this stuff is found exactly in the amounts that you need them in your vegetables. So yeah, if your parents be telling you eat them.
Question. So it kept alkaline. So I always hear that with batteries. So is that the same?
Yes. So I don't know if you know the type of batteries, but like Apple was I think they were one of the first devices like in that big whole battery, like the phone, because the phone batteries were real big on overheating, and then you had some that exploded and caught fire. But there were different types of ions that they were using. I think the lithium ion battery was the one that was like the biggest culprit for doing that. So that is what they use. So lithium ions are they're obviously very reactive, and they're also highly conductive. So they regenerate quickly. And with just a quick little charge, and they can hold a lot of potential in them, because they're so electron hungry, because the things on the far left side of the table only have one electron. So they in their valence shell, and the happy ones have 8. So you see how far they are from being happy, and so they're going to do whatever they can to grab as many electrons as they can to fill their valence shell. And lithium being one of the more the simpler ones, they they use that in batteries. But they absolutely, because I believe like standard batteries, they're sodium. Like the car batteries and things, they use regular sodium plates and stuff in there. So that's essentially what a battery is. It's one thing on your sodium is going to be on your cation end because it's positive, so it's trying to draw electrons, and then you're going to have some negative thing or something that's easily gives up electrons on the other side. Like you could have like cadmium. Like they don't do cadmium batteries anymore. I don't think, because cadmium is a very toxic heavy metal, and people not disposing of the batteries properly puts a lot of stuff in the environment. That's why batteries need to be disposed of properly, y'all, because the stuff in it, we're not supposed to be drinking it. But they'll have something on the other side that gives up electrons very easily. And so if your battery is dead, basically the cell potential between the two plates is basically homogenized. So it's basically given and taken all of the electrons it can, and there's no way to create that deficit or potential anymore to make the battery able to either charge or give any electricity. So then that's what you call it, a dead battery. So it's not necessarily dead. Like all you got to do is just clean the solution and stuff out. That's why I know you've seen people putting water in batteries and stuff. That's why they do that, to try and regenerate the electrical potential between the difference in the two plates. So they'll pour out the old used battery juice and stuff, but like I said, it needs to be disposed of properly. People aren't doing that. So yeah, but that's why they do that. And now the noble gases. So I like the word noble. So I'm gonna read the definitions of noble, just to kind of let you see where they're coming from. So you can pick up what I'm laying down or not. So I just went to dictionary.com. Nothing too extravagant. So noble, distinguished by rank or title, pertaining to persons so distinguished, of, belonging to, or constituting a hereditary class that has special social or political status in a country or state of or pertaining to the aristocracy, of an exalted moral or mental character or excellence, admirable in dignity of conception, manner of expression, execution, or composition, very impressive or imposing in appearance, of an admirably high quality, notably superior. And then they actually have the chemistry definition, meaning inert or chemically inactive. And I find it funny because when you think of inert or inactive, like chemically or otherwise, you don't think noble. Like you don't think like, oh yeah, they're totally not doing nothing. They didn't get to that status doing nothing.
Yeah.
So when you think of like noble, and then you think of like what the noble gases are, like it actually fits really well. So they're not quote unquote inert because they don't do anything. They're just not moved the way the other elements are moved, or to react to anything. They are so content and so happy with being by themselves, because hydrogen is actually a diatomic molecule. So if you find hydrogen just living its life, you'll always find it as H2. That's where it's stable. It's not doing anything. It's not trying to bond with anybody else. It'll hang out, but it only hangs out as H2 unless you have it in a solution of something that causes it to ionize or something. And there's a couple of other diatomic molecules like oxygen. What else? They're all in like similar group, nitrogen and so forth. So it's a couple of other ones that exist as diatomic molecules. Well, they're elements, but they're diatomic. So meaning there's two atoms. And noble gases are not. So they don't bind with itself. So if you see neon or argon or whatever other noble gas, it is not going to interact with itself. So it is largely stable and not explosive like hydrogen. So it was very good, I would say, that we found out about the noble gases, because a lot of the stuff that we use noble gases for, people were trying to do with hydrogen and stuff was blowing up. So, and especially with all of the neon lights and stuff that we use for advertising and, you know, directing people places and stuff like that, you wouldn't want a highly reactive, highly flammable gas, you know, hanging around in a restaurant that, you know, cooks food. Boom goes the hydrogen. Oh, and speaking of explosions, as you can see from how reactive the alkali metals are, they were definitely used in like early, development of like gunpowder. Saltpeter is, I want to say like sodium or potassium. I think it's potassium. It's a form of potassium, I want to say. But it is definitely one of the alkali metals in a odd form, and it's explosive. TNT, trust me, it's got that stuff in there. So, oh, she's upset. I don't know what set her off. But the noble gases, on the other hand, they don't do that. If you see a noble gas in a compound or bound with anything, that didn't happen naturally. Somebody did that to it. And when I say somebody, I mean nature is not going to force the noble gas to bond with anything for any reason. So that is kind of like, you know, your bubble, your BS bubble. Like, nope, I'm happy in here. What's that? No, I don't need that. and that's kind of like, you know, the noble air, like people call it uppity or sedity, but it's like, no, it's just understanding that you're better than whatever that situation is trying to make you react. And that's the thing, like you really have to sit with yourself. Like, am I happy being myself right now? Am I happy with what I got going on? Okay, then nothing else matters then. And that's kind of how noble gases go on about their business. Like, oh, okay. And then if you excite them, all they do is just show their true color. I'll bring the picture up for the gases, because they all do have their own distinct color. And the way that they make the different colors in the neon lights is they mix the different gases together, because, you know, it's like art. You know, if you mix red and yellow, you get orange. So it's the same concept with neon gases. So they all kind of glow at their own color when they're excited with electricity, or, you know, set on fire, or however you go about exciting them. They're going to glow a different color based on the type of gas or the combination of gases that are present. And lo and behold, they're the gases that's used in all light bulbs. So not just neon lights, they're actually also used in our regular light bulbs to make the filaments in your light bulbs last longer. So when your light bulb turns on, you got electricity running through it and it gets hot. So if that was occurring in oxygen, the friction of the electricity running down the whatever that metal filament will make the metal filament burn. It'll literally burn, you know, because oxygen is flammable. So, and oxygen feeds fire. So if you're sending electricity down, which is basically like supercharged fire, then you're going to burn that filament up very quickly. So they put these inert gases in the light bulb to protect the filament, reduce the friction, and make your light bulbs last longer. So when you hear that pop, that's the gas being quick release from the light bulb, not just the shattering of the glass.
Okay. Mm-hmm. So you remember how, like, you know, batteries die. Mm-hmm. So what happens scientifically when our light bulbs die? Like what?
Usually that's it. The filament just burns out. So like the noble gases, like they can extend the life of the filament, but it's not going to be, forever. So it does eventually just burn out. And then the filament, like if when it burns out, it makes a spark, and then it'll actually ignite the gas inside the light bulb, and that's why it explodes. Because now you have free electricity just like running out, because the filament guides the electricity from one side to the other and allow, the light to be its charge of energy. But once that little metal, strip in there breaks, now you have free electricity running around in there, and it excites the gas in the light bulb. So depending on what type of light bulb you have and what type of gas, noble gas that they have in the bulb, if you ever see, because most of us, we don't ever see the bulb actually explode, but it'll explode, and the color will match whatever color of the gas that was in there.
Right, because I know it's always be like darker for the most part.
Mm-hmm. Yeah, and for the bulbs that don't explode, you've seen the little char, like it almost looked like somebody popped a firecracker inside the light bulb. That's what that is. The electricity sparking the gas inside and, hitting the glass. But if it's not enough pressure in there, because sometimes like that little the little glass thing and the little metal thing at the bottom of your light bulb, it'll get loose. And so maybe the gases inside the bulb were leaking out and you just didn't know it. And so that's why not all light bulbs, when the filament dies out, that they'll explode, because there probably wasn't enough gas in there to make it explode when that happens. And they're colorless, odorless, so you wouldn't know. Like you wouldn't know if your light bulbs were all leaking, noble gas, because you can't smell it. But it's not harmful, because like I said, it's inert, so it doesn't do anything. And then radon is considered a noble gas. It has a noble gas configuration, but it is not naturally occurring. Radon is actually a radioactive, it's radioactive waste, essentially. So like bigger atoms have half-lives, and much of like that the two rows at the bottom of the periodic table that aren't really sitting in the periodic table, all of those are highly radioactive, and they have like half-lives of like, I don't know, like a couple, like 20, 30 years, or like some ridiculousness. Like their half-life is pretty long. So a lot of the stuff that's been buried or improperly stored, or before they had environmental safeties and regulations put in place, if the companies that dumped the waste went out of business, disappeared, or whatever, then obviously they didn't come back and clean up their mess once those regulations got put into place. So that stuff is still wherever they hit it. And it's breaking down, and the radon, it's a gas. It is a gas. It's not like, the sludge and stuff that we see in cartoons or whatever, the radioactive spider that bit Spider-Man and all. It wasn't like that. Or who was that? Alex Mack was the radioactive sludge teen with the superpower. So it's not like all, leaking out of barrels and stuff. It's seeping up, and it can, if it's buried, it can still seep through the ground, because it's a gas. So any type of disturbance or ground disturbance could release those gases, and if they get trapped in your home, you could end up with lung cancer, because it immediately like penetrates your lung tissue and stuff like that. Like it's some nasty stuff. But for the most part, most of the people in America don't really have to worry about that, unfortunately, because a lot of our companies did a lot of that stuff overseas. So because the regulations weren't the same there for a long time, like even because our EPA does not control the world. So the EPA was getting the stuff together here, and they were just doing it somewhere else because they couldn't do it here. So for the most part, unless you live, I guess, like near where they probably used to dump the stuff. Like I said, if they were a small company, they probably never went back and dug it up like they were, supposed to. So, I mean, you could test it. You could call your EPA and see if because they list all that stuff on the website, if they do testing in your area, and what they found, and if they're, what the levels look like. And I think it's probably some other non-governmental environmental organizations in your area that might do that too. And you can kind of just Google, do I got to worry about radon where I live, like radon gas where I live? And I'm pretty sure, you'll get some type of hit from it. And like I said, you can always start on the EPA website and kind of see, because they tend to give other organizations that do like more of the detailed testing in your specific area, because they wouldn't necessarily do that unless they're called out, on a tip or something like that. But that being said, argon is actually the most abundant noble gas? Oh, that's weird. The rarest. Argon is the rarest. Neon is the most abundant. And you would think helium is. It's not. It's super duper light. And so not a lot of it gets trapped in our atmosphere. And that's also why a lot of the other noble gases, like, they're in small amounts compared to whatever other gases we usually breathe in. So that's why, for the most part, they're kind of insignificant in our day-to-day life unless we like actively need it for something. And that's why, because they're rare, but they're noble. So they're important as an example. And that's literally what being noble is, just being an important example of the possibility of what it could be like to be noble. All right. Sitting on your tuffet, eating some curds and whey. I don't know why I always thought of that little rhyme when I think of like noble or like, the upper class and stuff. I'll be like, they probably sit on tuffets, whatever a tuffet is, eating some curds and whey. That's not a thing. It's a thing, but it's not. I don't think anymore. Maybe it's still people sitting on tuffets somewhere. But that's all I got for today, because baby.
Well, I really enjoyed that video, even though it shocked me. It literally dropped my jaws, but that was cool. That was cool.
Yeah, and as you can see, like, they call them soft metals, but like people think of metal as like being hard or like steel, but like there's different, it's a spectrum. It's a spectrum. You can even have metal powder. Oh yeah. So those are the gases when you excite them. So they're probably being excited with electricity from how it looks, but that's how you get the different colors. And then to get the colors in between, they just mix and match them until they, get the color they're looking for.
That is cool. And the brain, even though it was funny because you was like, I kind of went off track, but I enjoyed that when you was talking about the cerebellum and the left side and the right side of the brain. Because real quick, so my daughter is special needs. So she was born with something called septo-optic dysplasia. And she literally has, when I say a pin-sized hole in the left side of her cerebellum, I mean, it's like a sewing needle, tiny, like you can barely see it. But because it's your brain, literally, it's one of those, like, like diabetes causes like all types of stuff just from diabetes. So that's what septo-optic dysplasia is kind of like. So it caused her to be blind. She is nonverbal, all because that's all but the left side controls. So it's weird. So she's also on the autism spectrum. So she's nonverbal, but this young lady sings clear. Oh yeah,
I was just gonna say, I'm like, she probably like excels in some other form of expression. Or
yeah. And so I remember seeing to myself, I'm like, because to me, so like in order to sing, I learned how to talk first. I didn't start singing first. So it amazed me. I'm like, how do you sing so clear? I'm like, songs off the radio that there's no like confusion about what this kid is singing, but it's like, but you don't speak, consistent. And so my sister was like, well, that's because, so she's always like looking up stuff, like interested in stuff about autism. And she was like, I told you, because I seen that singing is controlled by your right side of your brain. So mind you, my daughter's birth defect is on the left side. So I was like, oh, because like for me, like I said, singing would be the ladder of after you learn how to talk in my mind. But because it's controlled by the different sides, I was like, well, that's interesting. So it was interesting listening to you. Because I'm gonna be honest, before I had a child, I didn't know what a cerebellum was.
Oh, yep.
Yeah, until that, then I had to get familiar with it. I'm like,
yeah, it controls all your basic motor functions.
If I can just add too, like that kind of like went back to what we were talking about with disability and inability and what's ability, because if you're not able to do something and I am, like going back to what you were talking about earlier, like you can't be the carburetor if you're the battery. And a lot of the times that's just adding to our own frustrations, trying to do stuff, be stuff that we were never designed to be. So even if the part we call, because I guess we're trying to say or determine norm, and it can't make sense.
And you can only do that by comparing people, but
right.
we're unique. So you're intrinsically doing the wrong thing.
Right. Do you understand what I'm saying? So then
literally apples and oranges.
Literally, right? But fruit. You see what I'm saying? When you categorize, it's fruit. It doesn't matter the type. We're all just fruit. And it just seems like when you're now looking at this, because my son is highly functioning, Asperger's with the autism. And it's like in the beginning, it was like he can't say go to the store, but he can say there's a dinosaur. Where did you get the word dinosaur from? Like this is I can't. I never understood it.
How many syllables?
Right? How many?
Seriously.
Okay. But it just taking it back to that whole theory. The girl, she lost her. Wait a minute. She couldn't hear. She's deaf. She was deaf, but she could sing. She could sing phenomenally. And she marked up her neck where she feels vibrations in her neck in order to sing it. And it's so crazy because I'm not being funny. I was just telling my other friend, like, there's something here in me when I hear music, certain things, like it's almost as if I can play like behind there's this frequency that's hit and it does everything.
Because that's where your vocal cords are.
Wow.
So they vibrate when you talk. And so when you talk in a lower tone, they vibrate slower, so they relax more. And then when you want to do a higher pitch, they tighten so that they vibrate faster and you get a higher pitch. So that's why she can feel the different vibrations. And then those muscles that tighten it and loosen it, they shift the vibration. So that's probably why she was able to work on the keys.
Right? So then so guess what? Guess who can't do that? We can't do that. She can't. In her world, are we disabled? Or are we able to do what we're able to do? If I'm armed, my only function is arm stuff. I don't do heart stuff. You know what I'm saying? It's just, I mean, it just all ties into, and it's just like, what is disability? What is an ability? What is inability? You know what I'm saying? We're part of a body, a unit, one functioning. I'm not going to ever be like you.
Exactly.
Right. I can't be.
Yeah.
And a lot of times, like, being not like the norm requires you to be excellent at not being the norm. So she was able to mark that on her neck because she was so like passionate about singing that she found a way for her to do it. And a lot of times we try and do stuff the way we see other people doing it, and that's not for us. Like maybe we do need to find our own way to do something so that we can show others like there's another way. Like you got to find it for yourself, and that's the whole point of putting your own eyes on the words, putting your own eyes. Okay. Lord. Like, I can't tell you how you're supposed to use this tool. Like, it is the best tool we've ever gotten. Before we got fire, before we got the wheel and all the other stuff, we had the word. Because guess what? It was with God. So, obviously, the word been around. So, obviously, it's the first tool God used. God showed up with the word. Okay, yep, we finna do this. So if it's the first tool that God reaches for, why isn't the word the first tool that we reach for? And it makes everything so much more simpler when you're finding who you are in this space, how you use that tool. Like, someone gives you a screwdriver and then you go and eat with it and they looking at you like you crazy. And it's like, well, I don't need to screw anything, but I'm hungry right now. So I don't have a fork. So I'm making it work.
I'm just saying, this is all I have. So I'm smart. And that's the thing about even just going back to, like, you know, with Black people and how we innovated the things, or rather recreated, you know, rearranged parts and the things, because we had nothing. So that's how it happens. Listen, I need something. I have to have a way in which, and I'm going to take something and shift it into something that's necessary. You looking like, okay, y'all use forks to comb your hair. They're going back to the dingle hopper. You know, I'm a huge
little mermaid.
You know it, the dingle hopper. So again, in their world is this, and in our world is one thing. But then does that mean, you know, it's wrong or right? You know,
exactly. And there's that word that's always thrown around. This ain't the right way. This is incorrect. But obviously it works for somebody. Once you remove yourself from that, from trying to force yourself to fit somewhere where you do not belong. Because a lot of times that's where it stems from. You trying to be somewhere where you don't belong. If you look up and you say everything is wrong with this place, remove yourself. That's the quickest way to find out you done made a wrong turn. If you look up and say, I don't like this, I don't like the day, I don't like the way that smell, leave.
Nothing's wrong with the place. The only thing wrong is that you don't belong there. So just leave and all will be well.
literally that. And just like I said, like, that's why I love science, because it really, like, the more information they get, the more they realize they don't know anything about anybody. And the more information that's available for people to learn more about themselves. So a lot of the case studies and the experiments and stuff that, you know, that they kind of have to compile for certain things, like I said, especially when it has to do with the human body, a lot of it is anecdotal or observational because of morality and ethics. Like, you can't just go fiddling with people and, you know, doing stuff that will probably kill people just to figure out how they work. So we just kind of watch people live their lives, and then when they die, people, you know, they figure out, why did they die? How much of this stuff that we saw them doing contributed to that? Like, that's what case studies are. And so the people that have enough of the same either symptoms or lifestyles have as many factors in common as possible, they kind of set those as the controls, and then the differences they look at as variables. And then whatever rate of death they notice, the people who did more of this and, you know, more of that. So everything is still statistical speculation. That's what I'm gonna call that. That's not what they call it. They call it fact or scientific back end and all. It's statistical guessing. Okay, they're guessing at, if you have these type of symptoms and you fit in this little demographic or group, then you're likely to have this outcome. Likely doesn't mean you will. Likely doesn't mean you are. Okay, and so we get caught up in a lot of that, and I would strongly argue that that's largely the reason why they talk against in the Bible, like seeing fortune tellers and stuff like that, is not necessarily because they're bad people. They probably have no bad intention for you, but the thing that they're offering doesn't exist. You can't see into the future. You don't know. All you know is what you're going to do right now. Yeah. And whatever you do right now, that's exactly going to determine your future.
Right.
And so when you go and you do that, you end up giving your right now power to someone who doesn't care about you past when you walk out their door. And so now you've gotten off the wheel. You done told Jesus move. You said, God, I got this. And then you're not even driving no more. So it's like, what's the problem? So
Madam Sinclair done told you.
Right. And so now science thinks that it has this gap or something that it has to fill with, you know, information as to predicting things or what. Nobody can do it. Nobody. Stop trying. All right. Stop. Just stop. So use the information to direct your current actions, your current choices, and that is going to determine the outcome. If you never work a day in your life, don't expect to be rich. I'm just saying, like, if you never get up, leave your house and do work and be in service of other people, you will never be rich. So if you don't do that, if you don't like doing that, then get your schemes together, because that's the only way you're gonna get rich, is scheming and doing all kinds of underhanded stuff, because it's not going to come to you that way. That's not how stuff is set up. Okay, you have to interact with people to get money from people.
It's so funny that you said that, because I remember reading something. And when you think about it, it's not just, it is literally the truth. If we think about it, your life is literally just choices. The outcome of how your life will play out in the moment and in your future is all based on the choices that you make, period. So yeah.
Sorry, my mama came. She was trying to find out what I was watching early, because I ended up watching something about relationships and stuff, and like, you know, where you gotta heal, and she had some real good information, I ain't gonna lie. And then I was watching something about anti-inflammatory foods. You know, I'm a nerd.
And listen, child, I'm like, what was on there? Because look, I got neck pain.
Well, and then that's the thing, because a lot of the talks were mostly geared towards people who have like inflammatory diseases and things like that, or where the disease is actual inflammation. So like lupus is literally a disease of inflammation. Like, that's it. Like, they don't know what causes it. They don't really know how to cure it. Like, it's just, you just get like real bad inflammation out of nowhere. And they've even said, like, even sunlight, just being out in the sun for too long or not enough. Like I said, like, they don't know. Like, because it's different. The onset is different for everybody that get it. And some people can, you know, get rid of it. Some people can't. But they're targeting more of the science on diet, because, you know, everybody's with the food. Yeah, Crohn's. Yep. Food is medicine. So now they're really starting to dial back I think they call it homeopathy. That's the term for regular medicine. So people who become doctors and go to school and take the Hippocratic Oath, I think that's what they call homeopathic medicine. Don't quote me on that. But the holistic medicine is what they call the stuff when you just basically eat your herbs and drink your teas and stuff like that. But I mean, there's a lot of other stuff that's shuffled into there, but for the most part, that's what they call it. But that was medicine. Like, when it all started and when we were all trying to get ourselves together and not die, plants were medicine. So it's like, you know, I'm not sure how they gonna call nature something else now, or make it seem like it's the other or alternative. They call it alternative medicine too. That's fun. So now they're starting to kind of, you know, dial back the sarcastic terms and stuff towards stuff that's actually working and actually helping people. So
they were much healthier back.
Exactly, because our diets were it was largely plant-based, but we weren't able to sustain populations on that, because you know, you only have so many plants in a given area. And then, you know, we started farming. So that's where the technology, and that's when technology first started to kind of grow and flourish, is when we started realizing, like, we're going to have to be the source of our own food. Like, we can't just kind of rely on whatever's available. We have to make it available. So they started domesticating animals. They domesticated plants, because essentially all the plants that we eat now, none of them are wild. You can't go and walk in anyone's forest and find any of the food that you buy in the grocery store. Like, you won't, because that's not how that food was made. The food was cultivated, and because you cultivated it, it automatically takes it out of its wild form. So if you grow wild plants, you're going to get wild results. So if you need to feed 500 people and you're growing wild plants, you can't determine if you're going to have enough of a harvest left to feed 500 people. But after you've cultivated these plants, you've you've bred it. So that's what where breeding comes in. Animals, to pretty much every animal that we eat doesn't exist in the wild anymore. Like pigs, a pig isn't necessarily the same thing as a hog or a boar. I don't even think they can crossbreed anymore because they're so domesticated. They're not really the same species. Like they don't even find each other, sexually attractive in that manner to where they would procreate. And with animals, it's all about do I want to have offspring with you? So pigs aren't bred to survive in the wild, and a wild boar would recognize that and wouldn't want to mate with a domesticated animal. So that's why a lot of zoos and stuff still exist, because even though the EPA and a lot of the animal advocate people and stuff like that were saying don't cage the animals and all that stuff, there's nowhere to really release them to because they've never lived in the wild. So a lot of zoos now are basically rescue shelters or centers for wild animals who have been displaced by deforestation, cutting down large areas of trees for whatever paper products and stuff that we use. And forest fires displace a ton of animals, pollution, a lot of stuff that we do to their natural habitats makes it hard for them to survive. And we've caused a lot of early extinctions of species. Like species aren't meant to be around forever. They absolutely do go extinct just from how evolution works. Like if a bird gets trapped on an island for X number of years, you're going to go back and you're not going to find that bird anymore because of it. It's specialization. So it ends up specializing on whatever it eats. So like if the bird gets stuck in its mostly flies or something and it eats mostly flies, its beak shape is going to change so that it can be more effective at hunting and eating flies. Its body weight is going to change so that the nourishment it gets from eating flies is going to be sufficient to maintain it in a healthy way. So everything about that bird is going to be different by the time you come back X number of hundreds of years later, and that the original bird that was stuck will not exist anymore. And that's just how nature works. So we are like super slow on that because we don't need to change, because we change our environment. So that's why we physically haven't really changed, like not in a natural way. So like that's why a lot of the changes that we are noticing, we're calling deformities or deficiencies or disabilities and all this other stuff because we caused them. But that doesn't necessarily mean that we weren't supposed to change in that way, because our bodies are super smart and they always adapt all the time. Every waking alive minute, whether you awake or sleep, every alive minute, your body is changing and adapting to your environment. So whatever is coming out, however our babies are looking, that's exactly the environment that we've been incubating them in. So
it's funny because you said something last show about how everything in our environment affects us, and like the things we don't even notice, like how they literally have effect on and I never forget, my daughter is 15, and it's so funny. So her pediatrician has been a pediatrician forever. Like literally, he was my pediatrician. I'll be 38, Lord willing, in 2 weeks. And I will never forget, he was like, this is crazy. I forget, he was like, I've been a pediatrician for over 30 years. He said, and once upon a time, a birth defect was so rare. He said, we did not see them. He said, now, he said, it is crazy the rate at how I am seeing all these birth defects. He was like, he said, and I would not doubt, he said, that there is something in the air. He said, because this is not normal. He said, the rate that we're seeing it, birth defects are supposed to be rare. He said, in all my career, he said, I have never seen anything like what I'm seeing now. Like what my daughter was born with, it's 1 in every 10,000 babies. And see, to me, it's like 10,000 life. He was like, for a birth defect, no,
because
that's not a big number. That shouldn't be.
Because having a baby is 14 trillion to 1. So having one baby is like impossible. So having a large number, like 10,000, is really a small number, because that's 10,000 miracles that you're counting. Like 10,000, oh, these babies almost didn't live. Like that's literally like the fact that you are alive and breathing and fully grown is literally a miracle. Like seriously. And yeah, so when they say like, oh, it's rare, like it's not, because the statistic doesn't go down just because there's more people being born. Like that's per birth. So
Right.
Yeah, when you guys were like kind of talking about food earlier, like linking things back to the cause, and that's environment too. Like think in terms of, again, it's like a world within a world within a world. So it's like the world outside of us, the world within us too. And in that world and an environment and the things that you're not even cognizant of that's going on within your body, and you have a baby within you. So there are so many things and elements that, again, this is why women are environment, period. We are to set atmosphere and set tone. So when you're eating improperly, that's the environment you're now putting within the new world, within your world. You know what I'm saying? And the product of that, how the baby comes out, you know what I'm saying? It's so funny. I hate to even say, it's kind of like the food you eat.
Oh yeah,
that's
seriously.
the smell that come out. That's the you know what I'm saying? And it's all about the environment that you're recreating. So think about that. Even just the horrible food you're putting in with no type of intent, no type of nutritional value for yourself. You're putting that into an environment and universe, and you're wondering why it's coming out smelling or looking a particular way. You know what I'm saying? And one thing, Doc, I'll bring this up because this is mind-boggling for me right now, and I'm still I was watching how the acid in your stomach is strong enough to break metal.
Oh yeah.
but then sis, it won't break corn.
And that's it doesn't break down most vegetables, because vegetable cells have a cell wall. So that's why eating vegetables is important, because they provide a lot of fiber, like, and that's why they call it roughage, because you don't break it down. So the fiber, the actual physical plant fibers, are literally and physically scraping the sludge off your intestinal walls as it's being moved down. So that's why eating so many vegetables is useful, but also because you have to eat a ton of it just to get the right amount of nutrition out of it, because we're not efficient at breaking down plants at all. And that's actually why our populations didn't really explode until we started farming and doing animal husbandry and domesticating animals and growing up our own livestock to eat, because we didn't have constant access to meat and stuff. And then the people who were eating the meat, they were probably the ones who went and hunted it, because they need more calories, they need more energy if they're chasing down animals and stuff like that. And then they're probably gone, so they're eating whatever vegetables or berries they can find while they're following these animals, or eating what the animals eat while they're following them. And then you have the people that probably stayed back and tilled the land, doing the field work and stuff like that. But for the most part, they probably didn't eat as much meat, because they didn't require so much of that type of energy. And you actually get a different I would say a different amount of the stuff that you can get. So yes, you can absolutely survive on a vegan, no animal byproduct or product, whatever diet, but how it affects your body is going to vary based on your genetic makeup. And so whoever your genetics were descended from is going to determine the type of diet that your body can handle. So I probably descended probably more so from the hunters rather than the gatherers, mostly because I have genes that code for more of the fast twitch muscles. So the muscles that you would use to run, either run from something or chase something down. So I would need a more readily available source of protein to feed that type of muscle, to grow more muscle. But someone who descended from the people who weren't necessarily eating the meat because they weren't hunting it, they didn't really need it, and they just subsisted on mostly grains and vegetables, they probably can flourish very well on a vegan diet, with the supplementation, because there are certain things that you have to get from animals you can't get from plants, because like I said, they have cell walls, and no matter what we do, we're not going to be able to break those down and still get it like in a useful form, because even some of the stuff like omega-3s, they're available in plants and fish mostly. So, you know, it's mostly in fish, but it's available in plants like chia seeds and walnuts and stuff, but it's in a different form. And the older you get, the harder it is for your body to convert it from the plant form to the bioavailable animal form. And so that's another thing. Like, that's why, you know, when you get older, your teeth fall out. So if you don't have teeth, you can't necessarily chew vegetables, but, you know, you can kind of gum down, you know, some mashed up meat or something, you know, a lot quicker. Because if you, trust me, if you can't eat like green leafies or the crunchy stuff, like, you're not going to attempt to eat that stuff. I don't care how small it's chopped up. If you can't actually like mash it down into a mush or something, and then that's where most of our plant processing occurs, is in our mouth. So chewing your food longer actually helps with digestion. Paying attention to what you're eating helps with digestion. You know, being consciously and actively involved in your meal is and even the preparation of it helps with digestion, because you're priming your brain, you're priming your body. It's like, oh, I smelled she cutting up peppers. Oh, we going, hey, y'all, get ready for them the anthocyanins. Oh, yeah, you got some what antioxidants too? Yeah, come on. Like, so your body already knows what compounds are in the foods that you crave. So we ended up confusing our body, because we might crave one thing and then we go and eat something else. So we think we're craving some nice greasy, salty fries, when really you probably just need some broccoli, because it has the zinc and magnesium in it. So those choices and understanding, you know, the signaling between our body in the environment and our genetic needs, because those needs change based on your environment. So if you're not in an environment where you're drinking milk, for instance, your body will stop producing lactase. Lactase is what breaks down lactose, and that's where lactose intolerance comes from, because you're no longer in an environment where you're drinking milk that has lactose in it that needs to be broken down. So your body stops making the protein for it, because that's a waste of energy and proteins and materials that you can use for something else that you actually are doing. So you can potentially, depending on like if it's genetic or not, like if it's not just like a lack of having that protein gene, then you can potentially become lactose tolerant again, by, especially if you weren't as a baby. If you were lactose intolerant as a baby, you probably don't have the gene, and you shouldn't drink milk unless with lactose in it, unless you want to be extremely uncomfortable. But if you weren't lactose intolerant as a baby, then you could potentially become lactose tolerant again by drinking milk with increasing amounts of milk fat. So like you would start with skim, then 2%, then, you know, then work your way up, and you can even split your whole milk with half water and then back up to whole. And there are some, you know, lots of benefits from drinking milk, but it's the overdoing it. And that's where we get into moderation. Okay, it's key. That's my soapbox. Y'all done got me all off on a.
Look, I'm sorry. You said clothes, and I was like, "Oh, can I ask a question?" And look, oh, I would be the kid that get pushed in the hallway because the teacher said class was over, but I asked the question. Like, why don't you just shut up?
I had to go back through the evolutionary history of civilization.
I'm the bully that's probably pushing you in the hallway like this. Did she ask one more question? Now, all the things she answered within this last hour and a half. You had one more question? Okay. I'll meet you outside the classroom, sis.
Right. But it's crazy, like how stuff can be broken down into so simple, the elements, just the elements in the periodic table, and then all the complex things that they can be a part of and that they can do, especially when you think about how all of those things relate back to the human body, which is largely organic material. So once we get to the metal section, I won't really be able to talk about that. It'll probably be more so like linked with technology and prosthetics and stuff, because prosthetics have been making some crazy leaps and bounds, and they are doing like some amazing things because they're really starting to understand the human brain a little bit more. Like they have, honestly, for me, they haven't even scratched the surface, but they're starting to understand the mechanics of it a little bit more, so that they can integrate prosthetics a lot easier and kind of bridge those gaps. So if people aren't trying to, put marks on their neck to sing, they could probably have a prosthetic voice box or something like, or, they'll have the cochlear ear plants, already for hearing assistance and things like that. But trust me, it's gonna get crazy. Like, and that's why I love like sci-fi and stuff like that, because it's like an incubator for the creativity and the ideas and the possibilities of all of this stuff kind of coming together as one. And then you see cyborgs and people communicating telepathically through chips, or you don't even have to have cards or anything, because you have whatever, a chip in your hat, or your glasses. Because when I get some more glasses, I wear them all the time. So if you already wear it all the time, like just throw a chip in it, and you don't have to pull out something to pay for your phone, worry about somebody stealing your whatever, because it's encrypted and you can just look at it, and boom, your food is paid for. Or you walk in the store and you pick up your stuff and you walk out and boom, they already paid for it, because they've already so that's like kind of where they're heading with the technology and the ease of commerce, because they want to remove as much friction between you getting that money out your pocket and handing it to them.
Just look at me.
Okay, they trying to remove all that friction between you and that dollar. So that's why I definitely am glad that we're doing this show, because I want more people, especially our people, to get in on this, because like I said, they are throwing money at these fields, because there is so much stuff that is just not known about the stuff that these fields work with. And so being curious is like your best attribute going into any of these fields. And I would say, especially for me, hey,
Hello.
Yeah, look, you slid through. And I would say, especially for me, being able to kind of not just sate but stoke my curiosity with more and more information. It seems like the more I learn, the more I realize how little we actually know about stuff, and it just makes me even more excited, because some people feel like, oh well, everything's been discovered, or I'm not smart enough to discover whatever, or to work this problem, or think through this, or solve this new. Trust me, you are. If you're curious, you absolutely are, because you'd be surprised at how unskilled the people were starting off with all of this stuff, with these bodies of knowledge that they're touting as fact now. A lot of that stuff was disproven by more research, more advances and stuff. And so George Washington was probably killed by his doctor, because what did he have, like tuberculosis or like the flu or something? I think he had something like that we wouldn't even like blink an eye at if a doctor told us we had. We go home, drink our tea, and lay in bed for a few days, and then go on about our lives. But because of the practices back then, they were doing the blood, the blood draining or leading, I forgot what they called it, bleeding. They were bleeding people, so they would like drain out pints of blood. Mind you, got like 8 or 9 pints of blood or something like that. They draining like 3-4 pints of blood, like half of this man's blood, and he's already like sick. And so yeah, he died the next day. And it was like, okay, well, what do you expect? Like it's a no-brainer to us, and we're not even doctors now, but these were physicians, people who went to university and got a degree and was entrusted with the leader of our nation's life, and they failed horribly because they just didn't know anything. And if people weren't curious enough to continue to investigate these fields and these outcomes and things like that, we would accept the first discovery as fact and keep it moving, and we still be killing each other, and ourselves unknowingly, thinking we're helping, and really we're the problem. So curiosity is key. Yeah, lobotomy. Oh yeah, that was real bad. Like that was definitely like the result of like some mad like psychiatrists, scientists, like, you know, they were doing a lot of experimentation on mental health patients. So a lot of mental health patients were either misdiagnosed or diagnosed correctly and then experimented with their medications and treatments and things like that. So a lot of the stuff that we kind of know works now came from those unethical, immoral, illegal studies on, you know, people who probably didn't have enough cognitive, you know, whereabout to even agree to participate in any of that stuff. And a lot of them, they either had like distant families or no family at all to you know, to fight for, you know, advocate for them and their, you know, their safety and their, you know, their moral boundaries and things like that. So and I'm sure it's still happening. I'm not even going. I don't put nothing past people. Like the horrible stuff that I didn't, you know, read up on, came across, people post, like nothing surprises me with people anymore. Like I done let that go a long time ago. Like we're capable of amazing things and we are capable of some of the most terrible things. And, you know, people are so worried about the devil and these demons. Be worried about yourself. Make sure you not one of them devils or demons running around here messing people over, because trust me, it don't need to be no dark entity doing none of that when people are more than capable of doing it themselves. So that's another thing you got to stop. You stop putting so much credit in the devil's hands. The devil is not nearly as powerful. Exactly.
Sometimes it's
not nearly as powerful as y'all give him credit for. And the sooner, you know, we all realize that, the better off we'll be, and we'll understand that the peace and the change is definitely up to us. And that's what we're working to accomplish here. Okay. I know, right? Yes. What is it, Tuesday? Oh yeah, it's almost time for RockTrue Beats.
I thought, because I was like, wait, how are they on here?
Yeah,
but I forgot we're
minutes.
different times than them.
Yeah,
we're Eastern and they're CST.
Mm-hmm. And it's still like 15 minutes still.
Yeah, because I'm looking like, wait, their show starts at 7.
Mm-hmm.
No, 7, but for them it's 6:42. For us it's 7:42 right now.
Yeah.
Well,
definitely a dope show. And somehow they talking about bees, but somehow they end up on subjects like this. And I think it's like, that's why I'm like, science is amazing, because it literally connects everything. Like when he was talking about the sound, like just the songs, the words of the songs, the vibrations of the words, like there's actual scientific evidence, not just from we looked it up. Remember, we looked it up. Dr. Masaru Emoto, he's a Japanese scientist who found out through the experiment of freezing water that words actually produce like vibrations, like certain type, like good vibrations, or what we call positive vibrations, and negative vibrations. So like if you use the words love, hope, care, you know, things that make you feel good, you know, words that make you feel good, and you speak those into water, and then he would freeze it, and then the snowflake pattern, or the ice pattern that would come from that would be these beautiful like spectral like floral designs. And then you say like horrible words like hate, ugly, stupid, you know, those type of things, speak it into the water, and then you freeze it, you get like these weird little amorphous like blobs and shape. And this is frozen water, it's the same water, they didn't add anything to it. All they did was just say these different words. And so imagine if you're being bombarded. Now, we don't get to choose who says what to us. That's the freedom of free will and free speech and all of that stuff that people do. So you can only control what you are saying to yourself, what you say to other people, because that vibration, it doesn't just go out. Your voice vibrates in your head when you talk. So when you're talking to other people, you're literally talking to yourself too. And so if you're speaking this out to other people, you are affecting yourself just as much as you are affecting other people. And so when he brought up that point about music, I was like, oh, look at that. See, this why I need to, because I would have definitely like nerded all the way out on that. And they've even talked about using sound vibrations to like cure cancer, break up tumors and stuff like that. Like they used certain frequencies and things like that. Like, and it's not like it's still a part of the experimental, treatments and stuff like that. But it has been found effective in like benign stuff, not like super aggressive, like stuff like that. But like if you got like a chill tumor somewhere that's too difficult to reach with like traditional surgery or actual going in and cutting, they'll actually use sound waves to either break it up or kind of dislodge it or even find it. Like that's what sonar is. That's how dolphins and whales see, like in deep, dark depths of water where there's no light. That's why whales can do that, because they send out these sound waves that bounce back and they can tell how far something is. They can even kind of gauge the shape of certain stuff. I found that out on the Wild Kratts. I don't know if you watched it. when they get in their little suits and they pretend to be like I love that. And and they have when it was like the platypus. The platypus actually uses like a kind of sonar type thing, but they have like the things on their bill, their nostrils actually pick up like the sensors or something. It was like some crazy mess. I'm like, animals doing that? What? So yeah, like stuff is amazing.
Just before we get out of here, just to add to that, I'm glad you kind of brought that up, because one thing, like you said, you can't control what people say. I saw a quote today that was like, it's not about what you say, it's how you say it. And that can be true. However, you can't control those factors. You know what I'm saying? That's just like trying to determine what the mailman got on. Don't focus on that. Focus on the message that is there for you as opposed to the outside factors. You can control how you receive it. So just as an example, like, with people, how I deal with people who I know don't like me, can't say, girl, I don't care. When I speak and I know they're not going to speak back, I heard them speak back. It's about how I receive the information. So I take in what it is I decide to take in that moment. And someone can say, oh, that was a negative situation. Not if I've chosen to always look at a glass half full. And one thing you were talking about earlier too, it's about training. So you go back to the milk element, and people who have, their lactose intolerant, you can train everything. You can retrain your body to do a lot of stuff. It takes the conditioning. It takes the time, but it also takes, like you said, you want to recreate that environment within yourself that's healthy, that has intent, that flourishes. Train it. You can take this body, expand it as big as you want, and then you can take it and make it as small as you want. You can make it as big as you want with muscles. You can you can do whatever you really want to do.
Yeah.
If you want to, So, yeah.
Yep. And that's why we're also so intrigued with Olympic athletes, because they're like the epitome of, if I like really like was focused and I trained my body to do this one thing, like that's what it could look like. I could possibly run this fast. I could jump that far. I could swim that long. Like, and when you think about it, it's like you don't know where those bounds are until you set them. You set the boundary. Your body doesn't do that.
That's right. Listen, you set the bound, and that's so crazy because I know. Okay, that's so crazy because again, it's like having a car. They built an entire car, and then the car speed is like 120 on the dash. Yet the speed limit in the environment that you're conducive to says you can't go faster than 35. The bound has been set, but you're not without limits. So you have to now, that's when you go back to 43 and 7 and you live in life on Autobahn. Your mind has to be on Autobahn. The sky is the limit because there is no limit. The limit never existed. You put the limit there. Yep. And all you got to do is replace it by what does he say? Go back to the word. Change your mind. Change how you see this moment. If you see it the way that you see it from a carnal perspective, yeah, it's going to be doom and gloom. But if you see it, and going back to just fight and flight too, like from a carnal perspective, fight and flight is the reaction. It is a programmed reaction from your nervous system. But then you can also train your body with his word. And now you can respond to the things that you would normally react to. So instead of you fearing things and you flight or fight. Instead, it's higher flight, higher thinking is what now happens. And then instead of fighting, you understand that the battle's already won. And going back to blaming the devil, please stop it. He's defeated. He is a roaring.
Done. Like, I'm so glad you said, because I was watching the homie Joe. And he brought that up about the roaring lion. He said the lion does not actually charge you. The lion will roar and it'll run towards you. It does like a false start to see what you gonna do.
To see what you gonna do.
And he said the best thing you can do is stand your ground, because the lion doesn't. If it's not hungry, it's not actually going to try and do nothing to you. And if it doesn't, and of course it doesn't feel threatened by you. You're a human. Like, you're not even as big as a, trust me, it's not afraid of you. It wants to see if you understand your power.
Teach. I'm so serious. And I'm telling you, I know the devil be sitting up on the sidelines like, come on, Jesus. Y'all, you know, dang go well. Now, I may have authored some stuff, but they co-signing. They co-signing, rearranging, recreating. Come on, man. It ain't the devil. It's you. Right. If you build it, they will come. He ain't talking about everybody.
Right.
I'm just saying, it ain't the field of dreams for nothing. You never had to show up to it. You know what I'm saying? But this is about you and controlling, like we were talking about, what you can control yourself. You can't control no other factors. You know, so man, this was dope. This was a real dope conversation. This is
I know, right? Well, because I mean, the noble gases are like real uneventful because that's kind of their nature. And then like the biggest bang for the alkali metals, we saw that. So it was like, so what y'all want to talk about now? Because I only got so many groups to go through on the periodic table. I ain't trying to run through it before the summer.
Okay,
but it all fine.
Oh yeah, for certain.
Yeah.
Well, on that note, that was a nice little close. Okay, so when you hear the lion roar, what you do? Stand your ground. Okay, and then you yell in that lion's face, rock truth or nothing at all.